physics. But today, what I got to clarify this particular thing about electromagnetic waves, it's kind of a develop a feel that what exactly this thing is in such a nice way that it cannot just be explained. What it exactly is something like this. Assume you have something like a very large water or river over here. What you do is assume you have this particular thing over here, this particular thing over here. I had already exemplified like this one. When you place them a little distance apart compared to their relative size, so what you can do is with the slightest motion of one of them, you can actually displace the another. With the slightest motion, you can displace the water around here, and this will be influenced over this particular thing that you have a slight distance apart. This is the electromagnetic field. What happens when you place a charge over one place and when you move it, so just with the slightest velocity, what you can do is at a very small separation, at a very small relative distance, you can actually create a field that is influencing all other charges in the region. This field falls off as 1 by r square. It means you increase the distance by 2, the field will decrease by 4. You increase it by 4, it will decrease by 16. Similarly, you increase the distance by 100, field will decrease by 10,000. That is the trouble over here. That with the slightest change in separation, field decreases real quick. Now the interesting point is that although this kind of these charges and electromagnetic field seems to fall as 1 by r square, that you are placing it over here, you are just changing this distance or you are giving it some certain speed, and at these distances it will be influenced. At farther distance, lesser influence, still farther lesser influence. But light from the sun affects us on earth. Light from the sun so far away, light from the stars so far away that it will take us billions and trillions of years to reach them, it still affects us at earth. The question is, how does it affect? Through electromagnetic waves. What happens that when you place this very far, then this slightest motion cannot influence this thing because field has decreased so much. But placing it in this water and oscillating it back and forth, this interesting point, wiggling it back and forth, that will kind of produce a continuous disturbance in this water, in this whatever medium you have, and then this will be influenced from this far apart. No matter how far apart, you can only wiggle it back and forth with higher and higher frequency, and this will get influenced. Similarly, an electromagnetic field formula that you study in classical physics is actually not completely defined. What happens that when you wiggle a charge back and forth, so what basically happens is it kind of influences other particles no matter how far apart they are by electromagnetic waves. There is no real or physical distinction between an electromagnetic wave and an electromagnetic field. A field and a wave are exactly the same thing, like something like this. For example, you have an electron over here. Electron is never at rest, never static. It is an elementary particle. In quantum mechanics, you can never have an electron that is over here at rest. Obviously, that violates Heisenberg's uncertainty principle, defined position and momentum. So what you can have over here, you place it, it will have its slightest motion wiggling back and forth. Due to this motion, you will observe the electromagnetic field at any point. The electromagnetic field at any point is actually due to the motion of this electron back and forth. You move it with higher, so magnetic field increases. So what happens, for the slightest frequency of oscillation, you have an electric field. For greater frequency, you have an electromagnetic field, magnetic field combined. When you increase the oscillation much that the electron is wiggling back and forth with more oscillation, then what happens, this electromagnetic field is kind of coming out of the electron. It is coming out through this region of space, and the field itself travels. This field travels in the form of waves. That here you had this kind of field that was coming out. Now this kind of field is getting separated from the electron. It travels with varying kind of you will see this kind of electric and magnetic field that will go up and down perpendicular. So when you increase the oscillation, a field becomes a wave. That is the interesting point. There is no difference between an electromagnetic field and electromagnetic wave. All you have to do is oscillate it with high frequency. When you oscillate it with still higher frequency, this electromagnetic wave becomes a particle. Like you have this kind of wave that you had over here. when you oscillate it with more frequency, this wave will become a particle. So what quantum mechanics says or what quantum electrodynamics says is that a particle, a wave, and an electromagnetic field, all three are just the same thing. The only difference between them is the frequency of oscillation of charges. That is the real difference. And there is like no other difference. So the thing is, I had been studying like EM waves for so long time. But what clarification I felt after studying it today, like I studied it from lots of textbooks, from all kinds of textbooks. But what clarification I felt after studying it today, it is just on a whole another level. Like
मतलब कौन सी बुक से पढ़े
Feynman
अभी?
lectures.
फाइनमैन लेक्चर। मतलब ये कौन सा पार्ट है, फर्स्ट सेकंड थर्ड?
First. In fact, second is based on electromagnetism, but for the introduction, first it is given.
अभी
Fine.
इंट्रोडक्शन अपना कॉन्सेप्ट क्लियर किया।
Like Feynman lectures, chapters are not arranged like that in a typical textbook. Its chapters are arranged more in a historical way.
अच्छा, इन्हीं की बुक थी क्या? हम लोग बहुत ठंडी में लेके गए
Six
थे।
easy pieces.
6 इजी पीसेस, जिसका मजाक बन रहा था कि वहां पे कहते थे 6 की किताब वहां मिलेगी। उसी गए।
हाँ. That was six easy pieces is a part of Feynman lectures. Six chapters of Feynman lectures.
मतलब इसी में से वो 6 चैप्टर दिया।
हाँ. Six easiest chapters.
उसका फिनिश कर दिया था ना वो।
हाँ.
तब इसका कम।
I don't know. I'm not planning there to target it like I did for
नहीं,
Crane.
आराम से लो।
Yeah, I was targeting Crane in this many days, but for Feynman lectures not, because this is a whole another thing. This is just too amazing to be targeted like this.
नहीं, मजा आ रहा है तो आराम से पढ़ो, एकदम रिलैक्स में। और देखना, मतलब एक बार मैं इसे फिनिश करो ना एकदम रिलैक्स वे में, कि फिर दोबारा उसको पढ़ना ना पड़े। नहीं तो अक्सर ये होता है कि एक बार जल्दी से फिनिश करो, फिर पता चला 20% अंडरस्टैंडिंग आई, फिर दोबारा वो लेके।
No, that is
क्योंकि
another
अभी
thing.
एक टॉपिक का कुछ प्रॉब्लम है तुम्हारा, और क्रेन में ऐसा तुमने कुछ पढ़ा है, फिर उसको एक्सपीरियंस की जरूरत पड़ी।
Yeah,
कौन सा
yeah.
टॉपिक था?
That in modern a certain part. Certain
मॉडर्न
part.
फिजिक्स।
Certain.
सर्टेन पार्ट।
Hmm.
ठीक है, तो मतलब उसको रिलैक्स में, जिसको अभी शुरू किए ना, जो भी जितना भी पढ़े अब एकदम रिलैक्स में। ठीक है, ऐसा तो है नहीं कि कल एग्जाम में तुम्हें अपीयर होना है, हाँ, या 10 दिन के बाद होना है। जब तुम्हें अपने लिए पढ़ना है, नॉलेज के लिए पढ़ना है, तो नॉलेज आना चाहिए, ना कि ये कि हमारा एक डेडलाइन तय हो जाए कि मंडे तक खत्म करना है या 10 तारीख तक खत्म करना है, ऐसा कुछ नहीं। तुम उधर टाइम बिल्कुल नहीं दे पाओ कि मतलब इसे कब खत्म की तो बात ही नहीं। जब हम स्टडी कर रहे हैं बेटा, तो खत्म करने की बात ही नहीं होनी चाहिए। हाँ, वो एक दिन में भी हो सकता है और एक साल भी लग सकता है, तो उस वे में।